स्टेट मशीन बना दी जाए।
Alright, that's just the opening to kind of give you the context behind it. How many of you were here last year for the Code Jugalbandi? Okay. So it was the last time was the first time it was debuted here at the Functional Conf. Dhaval and Ryan actually did the Jugalbandi where they kind of picked a couple of languages and then tried to show off how in this particular language a particular thing can be done, a melody can be played, and then they kind of went back and forth between the two, just kind of going through different melodies and showing how in different languages that could be implemented. So we were discussing that, you know, based on the success of last year, a lot of people liked it. We thought maybe we should open the floor to more people to come and do the Jugalbandi live on stage. So the idea is that we're going to, you know, quickly describe the problem that we want to we want everyone to work on, and then we would like people to come and kind of show off, you know, like in this language, this is how I can do stuff. And then someone else says, that's okay, but look at this, like I can do this even better, you know, something like that. And hopefully this would be more of a learning exercise for us to see how different languages try to solve similar problems in a different way. And yeah, that kind of is the context for the whole Code Jugalbandi.
Yeah. So, what we're going to do is picked up a small game that we almost all of us have played in the childhood days. It's Snakes and Ladders. How many of us have not played this game? Played the game, right? Not played is not there. So everybody has played this game. Essentially, there's a board, and it could have n number of cells, and you know, players take turn at playing this game. And say if it's my turn, and if on a throw of dice I throw say 3, and I move 3 positions, I hit a ladder. I can take the ladder up to 22, and then in case if I'm gulped down by a snake, you know, I reach the tail end of the snake. So that's how the game is played. And to reach the final cell, I need the exact throw of dice. Yeah. So. It didn't crash, yeah. So I'm just returning what I get, and now what I start out with is initial positions of the player. I'm not modifying the player positions, and I get, because I'm taking 7, I get all of them initialized to 0. Now this is where I really need to work out my logic in this particular function, new positions function. So the first thing that I'm going to do is add dice value to a particular player's initial position. Yeah. So for that, I'm going to clone this so that I don't mutate the original one. Yeah, and then.
So I'm gonna do this in Swift, Apple's language. So I've already done the code, so I'm gonna start where I started. So I had the game in mind, so the main thing came was that it's just a player, right? Okay, so a player rolls a dice. So I started with a test class where my first test is where I initialize a test board. So this is same as what Dhaval showed, that snakes and ladders in form of a map. And then I have the test written that if I initialize a user with the test board and I just roll the number, and then I assert the position. And when does the user win? If the state is 100. And I have bunch of
so as I said, I learned this morning that this was happening, and I was invited to participate. So I've finished coding, and I think I'll just trace through it. That's the way I think APLers would show each other their code, is probably to trace through it interactively. So I have this namespace called SNL, and I have an init function. I think this is quite typical of an APLer. So it takes an argument of how many players I want to play. So we're single stepping through the code here. And in fact, there are two parameters, because you can also pass in a random seed. If you want to start simulating lots of games, you might want a second argument to the function. So I ensure that I have two elements on the right, and I assign the number of players and the random seed, which means that if there's no second element, it's just 0, which causes an diameter, which is 1/10 of the row height, fully filled in, and with the color picked from the color array. So let it rip. Where did it go? So that was the initialization, and now we'll play it. Oh, somebody reached the end already. Okay, anybody else keen to come up? Otherwise I can spend another minute. You want more time? Okay, so, no? Shall I carry on, or is somebody ready to come up? Okay, 3 more minutes. Because there's something also about...
So, this is also APL. I haven't got a GUI, I haven't got any tests. I wasn't even particularly interested in having multiple players. I just wanted to look at the what I saw as the core algorithm is starting from position X. If you throw Y, where do you end up at? And I have this function to solve it. In APL, functions take 2 arguments, well, they take 1 or 2 arguments, denoted by alpha and omega. So this little function here takes some configuration information as its left argument. That is S for the size of the board, it's got 30 squares. F and T are the from and to positions. So F is a vector for all the snakes and ladders of where they start from, so that's the top of the snake or the bottom of a ladder, and T is the corresponding to positions where you end up.
So this is actually in Julia. Let me just make this bigger. Okay, so this is, right now it's like just the UI, like I need to complete this last function which steps the player forward. So how this works is initially there's the model. Yeah, bigger, okay. Okay, so I'm using these 2 packages called Compose and Colors. So Compose is a vector graphic package, and Colors is a colors package. So this is the model for my board. First, I have an abstract type called cell.
I'm going to be using PHP. Pretty uncool to do that. So yeah, I have this little which doesn't really have a UI, but it simply prints out whatever position the player moved to and then finally announce the winner. So my players happen to be different languages, and then new game is how I get it all started. Basically, new game can take the list of players, the mode that you want to use, easy mode or hard mode, whatever, and then the board size. So these are all configurable. I randomly create a board, so every time you play the game, it's a different board. It creates a random board, and then basically call.
So good evening, everyone. So I am a newbie to Erlang, so this is the first time I am doing anything over here. So I try to do a simple form of this game, Snakes and Ladders, on the Erlang side. So the code looks like. So I'm using the general behaviors what the Erlang provides. So we have a general server behavior where we can lots of users are simulated. So 3 users, I'm assuming like 3 users are playing over here, and each user take turn to toss the dice and accordingly moves up the ladder or down the snake like. So what I have done is like, so the first statement over here is a start link where it creates a gen server process per user. So X is nothing but a user and followed by.
All right. So the way this works is that so I first have a structure where this is going to be the game state, which is an atom. So in Clojure, I mean, I could have done it entirely functionally, but Clojure supports both paradigms where you can have a state mutated and also have the functional things. So I'm going to, the way I'm doing it is I have an atom which represents the game state. It's going to have a players, which is just a bunch of numbers in an array, and then it's going to have a board. Now the way board is having is it has number of cells in a board, and then it has a position of snakes and position of ladders. Snakes and ladders are just maps which say, okay, if you go from one place to the other state, and that is generated using just a map function, and then I just say a number of cells, and I mean I give the board a size, and it automatically generates a board of say. So if I say 10 by 10, so I give 10.
It was wonderful to see all different code. The game being rendered in different languages, and it's obviously the less the number of lines of code. You want to? Okay.
Okay, this is Groovy. Okay, I just implemented. I have not implemented the simulation, just the rules. I just quickly take a couple of minutes and tell you the way I started with that. So I started with the rules, and I just took the number of cells there and initialized the snakes and ladders. Then I started test driving rules one by one, and that's the way I got these functions. Game over. Then the moving to next cell based on the die rolling, and then I just had 2 more functions for applying snakes and ladders. So I test drive those, and then what I did is these are the regular functions in Groovy, but I converted them to closures, which gives them more power to compose. That's what I did on line 27, where I converted each of those next cell applies.
Ways to code the same problem. I hope you found it interesting. At least I found it very interesting, especially APL, and the way you showed in very terse code just in 4 lines, different data structures in PHP, just arrays, function composition, which you just showed right now, and reactive, where your data is being pushed. I wish I could have shown Scala, where I'm pulling, but we don't have time. But amazing. I mean, I hope I enjoyed it. How about you guys?
Yeah, just curious, which language stood out for you? Any particular language stood out for you? No, nothing. So Julia shines. APL, okay.
I really liked APL.
The algorithm I like from APL, and the out-of-box thinking I like Julia.
What about others? Anything else like? So the purpose of this was really for you to get like a quick sneak preview on the same problem, how different languages will approach it. Again, as Dhaval had pointed out, forget the syntax. It's more about the approach, right? And you actually can see that the language kind of changes your approach quite a bit. So that's kind of the interesting bits.
Yep.
I think we're running short of time, so we'll kind of quickly wrap this up. Thanks, Dhaval, for doing this.
Thanks.
And thanks everyone for participating.